Now I am. Oh, this is on. What time is it? Oh, is it 11 already? Sweet. Means I can start. You guys all set? Good? Yeah? All right. Hey, everybody. Welcome to me teaching you about the cyber kill chain and one, how shitty it is, and two, how you can actually use it to accomplish something. So my name's Amanda Berlin. Nice to meet you. Thanks for coming. Jason, you're late. So by a show of hands, how many of you have heard of this cyber kill chain or like the intrusion kill chain? Awesome. So that's by Lockheed Martin. Now, how many of you can list all 7 steps? All right. And then out of all three of you that can list all 7 steps, how many of you can give me a specific threat and actually what happens at each step? Right? Almost nobody. So at one point I couldn't, and I still can't for a whole bunch of different kinds of threats. I struggled to show how you can actually use the kill chain at all in an organization, even though I was being asked to do it over and over again by a lot of my customers. So I currently work in an MSSP, and we would have customers that would want to craft their defenses to the different steps of the kill chain. So they wanted different use cases, so like ransomware or an insider threat, something like that. And they're like, okay, well, are we covered at all 7 steps? And sure, I guess. Like, is that what your blinky box tells you that you're covered for, is all 7 steps? Because I have no idea. So some threats and attack methodologies don't fit in the kill chain at all, and we'll cover that a little bit too. Aha, so all 7 steps. So sometimes called the cyber kill chain, it's actually called the intrusion kill chain. They describe it as a model for actionable intelligence when defenders align enterprise defensive capabilities, so we're supposed to be aligning stuff to this, to the specific processes an adversary undertakes to target the enterprise. So advanced targeted attacks, APTs, whatever you want to call them. It's 7 steps. First step is GrrCON. It's where the attacker researches, identifies, select targets in your organization, crawl internet websites, they look for mailing lists, previous breaches, that kind of stuff. A big resource is like those previous breaches that have happened, all the information from those, LinkedIn, Google searches, your website, whatever. Second is weaponization. It's the automation of some kind of like remote access tool combined with a malicious payload. Third is delivery, which is the transmission of that weapon to the target, like drive-by downloads, phishing links, USB drives, whatever. Fourth is exploitation. So after the payload's delivered, and all of you, red teamers, this is kind of what you do sometimes, depending on the attack that you're trying for, right? And the scope. So exploitation is after the payload's delivered. That's when the code actually triggers. 5 is installation, and that allows the adversary to maintain persistence in the environment. 6 is command and control. So like you have a host that's beaconing out to some kind of command and control server that allows a client server thing rather than them having to manually control hundreds of thousands of endpoints. And then the last one is actions on objectives, and that's the ending. That's where they've gotten what they have come here to steal, whether they've created a hotbox for a botnet or exfiltrated information, popped a box and actually gotten the information that they've wanted to get, corrupted the data, whatever. So those are the 7 steps of the kill chain that, none of us really use. So what are some common threats that you can think of that are at the top of pretty much everybody's mind when they're crafting their defense plans? Anybody want to shout out any ideas? What's like the biggest thing you worry about when you're crafting defenses? China, right? APTs from China. state-sponsored actors. Ransomware, DDoS, some kind of Chinese data exfiltration. So according to this year's Verizon data breach, what's it called, DBIR, 88% of the breaches fall into 9 categories. So the same 9 categories were listed back in 2014, and they're pretty much exactly the same ones that we're worried about today. Cyber espionage from China or North Korea or Russia is number 1. That's the number 1 that people are worried about. Anything state-sponsored, and usually what we like to point to as an excuse for any attribution. Denial of service. You usually worry about denial of service if you're a larger corporation. That's usually what they're targeted towards. Crimeware, like ransomware, and then the next 5 are insider privilege misuse, physical theft, web app attacks, miscellaneous errors, kind of like the one that brought down Amazon, payment card skimmers, POS intrusion, and then that little sliver that's everything else. So what I wanted to do is break down each of the common threats into 5 categories per step. First, to understand and kind of map out the defenses that we need to systematically build and know what we need to do at each step. So first, we need to know what the malicious action is. After that, we can move on to specific defensive mitigations for each of the actions that we've defined. Sometimes there'll be more than 1 step involved because there may be more than 1 malicious action taking place at that, for whatever they're trying to accomplish. You know, defensive mitigations like change in processes, firewall rules implemented, new technologies purchased, that kind of stuff. Maybe something that you have for free in your environment that you're not actually taking advantage of. I also wanted to take everything and assign an ease of deployment to it, because a lot of times you know that there are these holes that are poked in your network, and you know certain technologies or steps that you have to take to get it taken care of, but you know, you may not have gone through all of the work needed to figure out how long it's going to take, how easy it's going to take to, you know, set all this kind of stuff up. So I also attached that to each step. And this is all in a big spreadsheet that I'll just show you in a second. I'm not going to go through the whole spreadsheet because that would just be torture. But you'll get all of this in a second. And then not only should we worry about defending against each action, but also correctly monitoring alerting. This will allow us to take reactive steps and aid in IR, and you know, have proactive steps to maybe possibly failed attempts that have happened previously. Let's see here. I'm going to show you the spreadsheet briefly, if I can get out of this. Let's see if it works. Oh shit! Wait a minute. Is it gonna work? Haha. Aw. Well, shit. You gotta click on the thing you want. Shut up, Johnny. Anybody know how to make this go to the screen? I did. It's still not working. Yeah, everybody just want to like file in a line and you can come past my laptop and see it? No? All right. Anyways, I will be releasing this gigantic spreadsheet that I have of all of these different wonderful malicious actions. It will blow your mind. It's the best spreadsheet in the world. We have the best spreadsheets here in America. You know, that's going to really screw like half of my presentation if I can't show things. But whatevs. All right, come on. Hurry up, hurry, run, faster. Can only like keep their attention for so long.
The stage is so huge. It's like a mile. What's the problem?
I want to make that go on the screen.
Oh, so you got to pull it out of full screen and then drag it over.
Oh, yeah.
to, okay, so, oops. Oh, you know, that's small. Where the fuck's your mouse?
Right there.
Okay, so, so you're to the right. So drag it.
Oh, look. Everybody give Johnny a round of applause.
It's over there now.
It's over there too.
Right, but you work like that. Be cool with that.
Yeah, I'll be maybe. I don't know. We'll see when we go back if I can actually do my presentation now too. This is a new laptop. Don't give me too much shit. All right, so right, best spreadsheet ever. Let's see if I can. You can't see any of it, right? But the idea is, anyways, you know, you have all 7 kill chain steps, and like this is for ransomware. Now I can't even fucking read it. So attacker obtains email addresses, technologies, and creates an organizational profile based on that information. The defensive mitigations go along with it, how easy it is to deploy those defensive mitigations, potential monitoring, and detailed alerting. Some of these actually give you, in the detailed alerting spots, what event viewer ID to look for. Like if Mimikatz is run, it'll tell you what to turn on and what event ID to look for when, you know, if a new process is being spun, something like that. And I'm going to try and make this like a community project, so if you have any ideas of shit to add, we can put that in there too. Gives us an idea of what is tied to each level of the kill chain for all of those customers out there that want that. All right. Let's see if I can get this back. No, I just have to find my mouse is all. No, I got it. Maybe? Yes. Aha. I swear to God I've been up on stage presenting before, I promise. All right, so we've made it through all that crap. It usually is worse than this, so you're welcome. So now that I've completely lost my train of thought, we'll just start with this. This is Microsoft's version of the kill chain. Instead of it being 7 direct steps one on top of each other, they have this crazy loop-de-loop roller coaster thing. Right? Hold on, I'll get to the next one in a second. I don't want to skip ahead too fast. So no two networks are the same, right? Anybody that's been in more than one environment, whether you've been defending it or attacking it or being a sysadmin, net admin, whatever, you've never defended it or attacked it the same way twice. This is kind of what Microsoft was trying to do, as opposed to the Lockheed Martin thing, kind of showing you that it may have like these loop-de-loops where it's not just a straight line every time. And they even have a little angry roller coaster guy. So the first one was low privilege escalation, actually obtaining a foothold. This second loop-de-loop is when the attacker actually has a foothold on the network, what they might be able to do. This lists as weeks, when the previous one lists as months. As an attacker, you know, I mean, sometimes it may take you 5 minutes to gain a foothold. It may take you, well, very rarely will it take you weeks or months. But they're kind of trying to give you an idea that it's not just super straightforward, as the other kill chain kind of puts out there. And a lot of people bash the kill chain because of that. There's so many different kinds of attack paths, and you can't really shoehorn them into anything. So now we're going to go on to one use case. I actually have 4 of them in this talk, but this is also meant to be a 3-hour talk. I'm not going to stand up here for 3 hours. I'm pretty sure they'd kick me off the stage. So I'm going to try and at least make it through the first one. There's also a bunch of demos, but none of you have the labs and stuff like that. But I'm still going to go through some of them if I can figure out the whole screen thing. One major threat I wanted to cover is ransomware, because a lot of times that's what people want to protect against. It's, you know, at the top of their minds. Over the last 3 years, it's jumped in popularity like crazy. And as we go through all 7 steps, not just with this, but with really anything, it should be our goal to make it continuously harder for the attacker. So it's like a funnel. Everything on the outside, you're going to want to make, do as much as possible. And as you get more into the inside of your network, you want it to funnel down so even less and less is possible. There are other methods that I'm not even going to cover that kind of bypass all of the kill chain stuff, like zero trust networks and stuff like that, but that's completely outside of any attack methodologies that we could cover here. Let's see here. So, malicious actions for ransomware. I'll go through some explanation of certain sections, and we'll do hopefully some of the little walkthroughs that I have of demos. And first up is reconnaissance. So the reconnaissance malicious action for malware, and really for a lot of other different kinds of things, is open source intelligence and those breaches that I talked about earlier. Even before any type of incident or attack happens, you should start prioritizing and taking action on what might happen. Things like risk analysis, business impact analysis, threat analysis, all of those come into play when defining defensive strategy. That's the whole basis of defensive security. But so many people stop at the basics, or sometimes can't handle the basics. They think that the first couple of steps in the kill chain aren't worthy to defend against. But I tend to disagree, just because there's a lot of stuff that you can do out there that can help protect you against those first couple steps. Yeah, man, you know how many times I've seen this guy's face too? So this this is a couple examples of when I participated in the DEF CON SECTF. And if anybody has either seen it or heard about it or whatever, the Social Engineering Village puts on a CTF every year where you kind of sign up and they give you a company name. And the year that I did it, the theme was around telecommunications companies. My company was Frontier. And I was able to, through open source intelligence, find a whole bunch of stuff about the inside of their network, or their practices and stuff like that, through that SECTF. And these are a couple of different examples. Like, sign in with your organizational account to something that's super easily spoofed. Probably doesn't have two-factor auth enabled. Doesn't have a signed cert. Knowing what kind of stuff is out there about your organization. What is out there that shows up on Shodan? What is out there that shows up with any of the other OSINT tools that you can use? Knowing what you have out there as far as assets go is really going to help aid in the defensive step of that first reconnaissance kill chain step. So at this point, it's not really defensive mitigation more than like a defensive proactive measure, but you can create policies around sharing internal information, like that last guy. You can go back to him. In a better resolution picture of this, you can zoom in and you can see what kind of PCs they're using, the fact that he has Internet Explorer and Adobe Acrobat open. That was on their public Facebook page that they used in, it was like some kind of highlight our employees thing. Something that you can do is canarytokens.org, where you can set up different like super easy honeypots they have. For monitoring and alerting, still on the reconnaissance step, you can, there's a couple different things you can do to be proactive. So after there's a major breach, go and have everybody reset their passwords, because Lord knows if they've reused their passwords, right? So, they probably have the same Equifax password as they do to log on to your domain. Force a password reset. Have corporate emails been in another breach that's happened recently? How many emails have you found using your own OSINT? There's a tool called the Harvester that I'll show in a second. If you can just run that against your own domain and see how many emails that are out there, and if you find an email publicly accessible or listed on the internet somewhere, it's going to be targeted and attacked by bots or whatever. So set up honey accounts. if you control the domain that your organization used or have some sort of say in what's in there on there for content, you can put a like a honey email address out there. So like on this slide up there, I have an email address embedded, just the same color as the slide background. Who's going to see that? Your customers aren't going to see it, but bots are. Anybody that scrapes your website is going to find that email address, and there's never going to be any legitimate traffic going to that email. Oh, here we go. So one of my favorite tools I like to use to demonstrate is the harvester that I just talked about. And learning what the attackers have access to out on the internet is one of the steps that you should take as a defender. Let's see if I can do this now without having Johnny up on the stage.
I don't like being on stage.
Right. Right. Oh, yeah.
Next time you get Jason.
Uh-huh, suckers. See if I can log in now. I'll say that it's probably like corrupted or something. It's supposed to do that, right? Yeah? All right. Do. Yay. And don't judge me because I'm going to log in his root. That's not your password too? It's all dots? No? Yeah? All right. This is great. I also want to tell you, you're totally my guys' guinea pig because I'm giving the 3-hour one on Monday. Although I hope I'll feel a little bit better then. O'Reilly Security Conference in New York. Zoom in. Zoom in. Zoom in. Zoom in. Zoom in. Tell me when to stop, guys. Good? All right. Thanks. Do. So this is the harvester. Super easy and simple. Just download Kali and run this shit. Come on. So if you run just the harvester, Python the harvester, it'll give you a big list of giant list of different things that you can do. Like, oh, you're gonna let me scroll? Yes, come on, you can do it. So -D is domain, B is the data source, so you can look at just Bing or just LinkedIn, or you can look for all of them. You can verify and resolve the host names. There's a nice one at the bottom that's -H that'll actually show you what Shodan has listed for those hosts. And of course, because we're awesome, we are going to run this against Equifax. So Equifax.com, so -D for domain, Equifax.com, -L for length, because we're only going to do 50, otherwise we'll be here all day, because they have a lot of shit out there. And -B is the sources for all. Oh shit, I'm not on the internet. I have one, give me a second. In your mind, just think that this worked. Do. My mother. And you were online? Yeah. It's fantastic. I even specifically charged it for this. Let's go back. Ah. Internet's a fantastic thing. Oh, it also searches PGP key servers. Do. Well, let's go. Huh? What? I don't know any jokes. What do you call a bear with no teeth? A gummy bear. I only know that because I wrote that on my 5-year-old's lunchbox yesterday, the other day. No, I didn't include gummy. Of course not. Mom of the year. All right, while that's going, I'm just going to go back to my slides. I'm not going to show you the slides because you can watch this. It's way more entertaining than my slides are. Why is this taking so long? Does Bing really have that much information? I don't know. What's that? Oh yeah, for OSINT stuff? Mother. Thanks. Now flocks of people just start leaving. So fuck that. So we're gonna move on to the next one instead because Callie hates me. This is one of my favorite things to do now that we're on the second step of delivery. So there's a handful of different defensive steps that you can take at this point. I know this is just like Johnny was saying in his keynote, how many times if you're the one that is the one doing the patching and people just say patch your shit even though you know it's not possible to patch XYZ box or whatever. Something that people also say is disable JavaScript and attachments, right? Don't let JavaScript run on your network. Don't let macros run in your environment, anything like that. So I know there's a lot of work that it takes to get there, but these are some of the things that you should not be allowing run on your network, if at all humanly possible. They're rarely exchanged from external sources unless you're doing a lot of JavaScript coding, and even then there should be a standard procedure that you go through to obtain these from external sources. It shouldn't be email. Implement scanning for these types of things or just outright block them altogether. Instill the idea of trust but verify to your users, implementing correct user education, blah, blah, blah. Installing ad block across the organization, sure, it might break a couple things. But like with everything that you're going to try and shift, you're basically shifting how they do their job day to day, unless you're only a security company. A lot of the time, implementing an ad blocker or turning off JavaScript from being able to run is really, really going to harm a lot of what people do day to day. You want to do it smartly, roll it out. Just don't do what I'm going to show you all together because it's just going to break a lot of shit. And we'll see about showing you this now. And hey, let's go and see if this actually fun. Aha! Look at that! If we go back up here, now that I finally looked at everything, going back, ta-da, bunch of Equifax emails. So run that shit against your own domain. See what's out there. Those are the kind of people that are going to need more user education because they're going to be attacked a lot. It's going to be somebody from HR. It's going to be somebody that is in your finance department, and they have a lot to lose. There's a lot of either customer records or employee records or financial transactions. Those people should definitely have targeted user education. And I'm going to show you how to make it so a JavaScript file opens up in Paint. Maybe. This is a train wreck. And I don't even feel that bad. I wasn't here at all yesterday. Please wait. Oh man, there's no way I'm getting through all this stuff. We are going to try and find my mouse again and come back to that. Fantastic. So, file types over a certain size, like JavaScript, screensaver files. Anybody remember this as like the, what, Windows 95, 98 screensaver? So, JavaScript files over 15 megabyte, screensaver files over 22 megabyte. Just block all that shit. If you can't block everything, block those. And then during the exploitation phase, this is I know this whole meme went viral. This is my favorite out of all of them. During the exploitation phase, the endpoint downloads a malicious JavaScript file, Microsoft Word, or document with another malicious macro. Those can come from attachments in the email itself or a link in a drive-by download. As we've seen more recently, there are ways that you can spawn off malicious payloads without using a macro. But hopefully, if you're at that point, you actually have an endpoint product that knows that you shouldn't be running PowerShell from a Word file. That's a whole other ball of wax. And there's a shit ton of stuff you can do in group policy. Like, it amazes me how little group policy is actually used in an organization. Yeah, it sucks. Like, I did group policy management forever, and I was to the point in one organization that I printed out all of the settings from all of the different group policies and had them laid out on my desk and was using a highlighter to try and figure out what was best to go where, because it sucks. Like, doing group policy is not fun. Being able to start over from scratch is fantastic. If you have the ability to do that, use group policy until, you know, you pass out, just because there are so many different settings in there if you're in a Windows environment that you can use to your advantage. You can disable macros via group policy. You can, what are some of the other things that we did? You can use, let's see here, NIST. If you go to NIST's website, they have a whole lot of different group policy downloads that you can do that are just completely hardened endpoints. Include that in your images, right? If you're going through and imaging any of your boxes, make sure that's included. You know, then you don't have to start from scratch with all of the security settings in group policy. Let's see. If I finally have Windows up. Good Lord. Ha ha ha. Nope. Nope. So, funny story. Motherfucker. Yes. Funny story. Who here has ever heard of or implemented LAPS? Local admin password solution? Okay. I had never actually done it before. I just told people to do it all the time. Because great, the idea is it will change all of your local administrator passwords to something different. It's saved in Active Directory. Yeah, it's saved in plain text, but hell, if somebody's on your DC, at that point you're fucked anyways. But turns out it actually changed your domain admin password. So I only had my one DC and my one test box that I ran it on, and it worked great until I rebooted my DC, and I couldn't get it anymore because it changed my domain admin password. So we won't get to even close to that part of the demo. But if you ever implement LAPS or tell people to implement LAPS, make sure that they have another domain admin to log in with. So, whoa, shit. Windows sucks. I can't see. I might just skip all this because this is a disaster already. Nope. Oh shit. Eh? Nope, it's still gonna suck. Alright, sorry guys. Completely ignore me. Well, not completely. Nope, it's not happening. Somebody come up here and help me. No, you don't have to come help me. I'm just gonna say fuck it. All right, this is fantastic. So, we're almost done with ransomware, I swear, even though none of my demos have worked. Well, one kind of, like halfway. So, unless any of you feel like me installing ransomware at my box, which at this point I might, at this point in installation, the payload just executed on the end user's device and it starts encrypting all their shit. So, defensive mitigations. What can you do to defend yourself against ransomware? Keep backups. I know everybody screams about keeping backups, but actually keep them, test them, you know, constantly. Take into account your DR plan, RTO, RPO, all the things that go along with disaster recovery plans. Depending on your operating system, you can use file system firewalls to protect against different things. Like you can permit read access to certain files with Word, but not with other things. There's an experimental thing that can block crypto-based ransomware, but it's not really an enterprise-level thing called Decryptonite. And also have a portion of your IR procedure set aside to, hey, I know you should never ever pay the ransom, but there's certain points where that's your last option. You definitely need your data back, whatever. Have some Bitcoin already purchased. Potential monitoring. You can find out when your files start getting encrypted. A lot of the different ransomware variants use the built-in Windows Crypto API. So if you see a huge spike in Crypto API in a local box, chances are it might be ransomware encrypting the files. You can also not necessarily alert on every time because we know how reliable threat intel is. But if somebody's contacting a known command and control server, that can be used in some of the alerting. And implement DNS sinkholes. Super easy. If you control your internal DNS, you don't have an appliance or whatever, setting up an internal sinkhole DNS for bad traffic is a lifesaver. I had run an internal phishing campaign at a hospital I worked at, and we were able to take a user that had legitimately gotten phished and black hole DNS or sinkhole DNS, that IP address and the IP address that the mail came from and everything else that was that link was talking out to in the matter of minutes. When you control that kind of stuff, you can rely on other people's intel to block known malicious websites and stuff, but you can also, add your own information from your own internal IR. This is great. SANS has a couple different things listed that you can use to either completely block on or use as part of your threat intel feeds. Things like Tor exit nodes and all the command and control bot servers, stuff like that. They also have a section of their website that they have like, I can't remember what it's called, but they list different, like we're super sure this has always been ransomware and always will be ransomware, and we've had this on this list forever, down to the ones that they're less sure about. So on the higher lists, where they absolutely know that it's not like on a shared hosting or, you know, just somebody's cable modem that's gotten popped, you can just outright block that shit. Like do some firewall additions of those lists so you don't have to even worry about anybody contacting those IP addresses. Huh. SANs. And since I can't seem to do anything up here on the screen, if you want to find me later, I can give you the links. This is a Wireshark capture showing some ransomware going out and using domain generation algorithms. So there's a few IPS solutions that have rules surrounding that kind of stuff, but if you ever see that kind of stuff in any of your packet captures or on your network anywhere, that's not legit traffic. I mean, nobody's typing out that domain to go to it. That's obviously command and control. And we've all seen this screen. Now we're on to actions on objectives, the final step where they're actually encrypting your shit. This is something awesome that I would also show you in a demo, but Lord knows how the other ones have gone, so I'm not gonna. These are honey directories. There's a simple simple PowerShell script that you can run that does, it creates a loop mount point on the C drive of $$. Usually when ransomware goes through and it starts encrypting your files, it will start at $recycle bin. Because it's doing it in alphabetical order, it starts there first. So it creates that loop point, and it's C:$ and the ransomware just starts going into those directories alphabetically when it's not actually encrypting your real files, but it is accessing those honey directories. You can alert on any access, and attempted access or attempted writes to those files, and it's going to tell you right away that, I mean, every now and then I'm sure you'll get a false positive of a user going onto their C drive and saying, oh, what's this? But chances are it's going to be a great early warning. I say early warning, but at this point you're already at step 7. It will tell you before the user does, though, right? And this is, the PowerShell script is from Free Forensics. I also have the link to that if you want it. So you can, this is that advanced auditing, right? So if you turn on auditing for in-group policy, you turn on advanced auditing, and you go in, and there's settings that you can create on the file system for that, that loop, that mounted loop. This is what it would actually show you. Like, can you see when the file system started, or the ransomware started encrypting the endpoint files? Like, this is a huge spike in file auditing traffic. Yeah. I mean, it doesn't look normal. And now, just close your eyes, because I have to, like, fast forward through all my slides for the next, like... Nope, ignore all that. Yep, ignore. There we go. So that's me. I'm all done. I'm sorry it was such a shitty session of demos, but thanks for not walking out. That book is available. I swear it's better than me talking. It went through like 10 editors, so. Was it better than Johnny and Jason's? Perfect. Yes. The bar's low? I'm going to blame the... Never mind. So, any questions? Come on, throw me something. No? All right. If you want any of my links or anything, feel free to come up. I can give you my slides. And... You can't get it yet because I have to wait until after Tuesday. After my 3-hour one, I'll be releasing it. I'll just tweet it out, and it's already open for comments. So if you have any other ideas of attacks that have happened or other paths that you've seen that you know of that have defensive mitigations to go along with it, just let me know and we can add them in there. Thanks, guys.